Hi everyone, this is Suram Sharma here, and I'll be your host for today, tomorrow, and day after tomorrow for 3 days. You'll have to bear with me, but yeah, and I hope I'll be a good host for all of you as well. So, as Yulia has announced, that we'll be having our competition, right? So, this competition is based on the regression model. The model that we are going to create will be a classification model for today, and we'll be trying to upload it, or you can say put it up on a front end using Streamlit. That will be done tomorrow by Promith. And today I'll be showing you a basic idea on how linear regression works. Okay, and I won't be showing you very in-depth idea because then the motto of the competition won't be left out. I'll be showing you a basic machine learning on linear regression and how it is done, and then you can try out utilizing the Tensor Flow as well. If you are not much more versed with the Tensor Flow, that's okay. You can try the machine learning part, the basic machine learning part on the regression part that I'll be showing you today. So I'll be showing you on a data set which is very simple one. It's just 30 data points that we have, and I'll be displaying it to you in couple of moments. But before we proceed to that, I just wanted to give you a basic idea of what I do, what background I belong to. Okay, so I started my data science journey like 8 to 9 months ago. Okay, and since then I have been working with Zipline as marketing lead, and I utilize the marketing analytics to build up a strategy around the marketing as well. Okay, and after learning, Promith and Anugna were very supportive during the entire journey of this thing, of my learning process as well. And right now, I think I'll be proceeding with future that I'll be doing. Will be in MBA, or you can say MSc or something like that. That is another part. But yeah, that is the future goals of mine, and that's where I'll be headed. Okay, so at the end of these 3 days, you will be coming to know what excites, and why TinyML is very much important in these revolutionary products. You can find out a lot of new products that are already available in the market that may be using TinyML, but what Newton is using, okay, it is embedding into a microprocessor, which is, as you can see, it's 1,000 times tinier than the normal machine learning models, okay, or normal TensorFlow models. Okay, you'll be getting to know all that within this time frame, within these 2 to 3 days of time. Okay, so yeah, let's get started on that. Before that, we'll be sending out you'll be getting a pop-up for polls. Okay, so you can try to attempt that poll. Okay, and once you are done, you can just comment in the chat. Okay, and during the entire the session for today, tomorrow, and day after tomorrow, you can also interact with us on the chat. You can interact with us on Slack, on LinkedIn. So we are available everywhere for all of you guys. Okay, so I'm just launching the poll right as of now. So just give 2 minutes of time, fill it out, and put up your comment in chat. And do let us know once you are done with the poll. Okay, your poll should be coming up any minute now. All right, I hope you guys can see the poll right now at your screen. So try to attempt it, and let me know once you are done. You can just put it up done on chat, and we'll begin with the session now. I'll be on mute for time.
Do we also do that, the panelist?
No, not needed.
Okay.
I know you are tempted to attend it.
Okay, it's written. Hosts and panelists cannot vote. Okay.
Okay, so far I just got 4 answers, and there are like 14 people. Come on, guys. At least attempt this out and
It is
share with your.
protected. We are not able to select anything there.
Sorry.
Those checkbox radio buttons are protected. We are not able to select anything there.
You should be able to select, I guess.
No, couldn't do that.
1 second. Yeah, try now.
Yeah.
Okay, so far we have got 7 people who have answered. Oh, okay. Now I guess why you may not be able to do it, because I can see 2 other Suram Sharma as well on the panelist. I guess. So that maybe you must be utilizing the link that I shared it over there. That's okay. That's okay.
Okay.
Yeah. For now, it's fine. But maybe from tomorrow, you'll have to utilize the links that that you may be getting on your email. All right?
Yeah, sure. Okay.
Great. Okay, so we have got the polls done. How many of you have already attempted? So we got 1 by Omkar. Great. And how many else are pending to attempt this? Okay, so there should be, okay, I got 8 answers as of now from 16 of people, so that's just 50%. I'll still give a minute more. Yes, Omkar, we can share the Slack link. Yulia, could you do the favor, please? Can you share the Slack link over here in the chat box?
Yeah, 1 minute.
That will be great.
I will stop to share my screen.
Okay, so guys who have just attended, who have just entered the, this room as of now, you can try to attempt the poll if you can see it. Try to attempt it and we can get started with that then.
Okay, now you have a Slack link in a chat. Please double check.
Yeah. Thank you.
Mm-hmm.
Omkar, there you can attempt all the you can get all the information about the future event that we will be doing also. And apart from that, I think Alex will be putting up a lot of other events also. Okay, and a lot of other blogs, posts, and many other things are being shared over there. Okay, so be a part of it. You can connect with me, Julia, Promit, Anugna, with any one of us, and we'll be helping out to you in any way that we can. Okay. Thank you. Welcome. Okay, I am about to end the poll as of now. If anyone is pending to give out the poll answers, you can try and give out in another minute, and I'll be ending it in, you can say, last minute now. Okay, all right. I'm ending the poll as of now. Okay, so we have got 3 data analysts, 1 business analyst, 3 junior data scientists, and 1 analytics manager. Okay, that's good. Okay, so out of you all, how many of you are aware of Tensor Flow? Already who is working with the Tensor Flow department, or you can say working in the data science domain. So you must be willing to do the TensorFlow part. That is a bit more into the deep learning part still, but I just wanted to know how many of you are actually aware of TensorFlow. You can put out your comments and okay, wow, nice to know, Omkar. Okay, all right. So right now I'm sharing my screen and we'll be starting with the basic linear regression part. Okay, what linear regression is all about. We'll be talking on that. Give me a minute. Just 1 second. Okay, just let me know if you can see my screen.
Yes, we
You
can
guys can
see
see
your
my
screen.
screen now?
Yes, we can.
Okay, that's good. I'll just put this one on the side. Okay. So what is linear regression? Why do we use linear regression and how we can utilize it in the current data set that yeah, can you guys see my screen now?
Yes, we can.
Okay, all right. Sorry, I thought that bad network, but yeah, all right. So linear regression. Why do we use linear regression? What linear regression is all about? Okay, I'll be just talking to you with just 10 minutes of time, and then I'll hand over the stage to Anu. She'll be taking care of the entire, the classification part. Okay. Okay. So what linear regression is all about? So linear regression will give you a predicted value, okay, based on the entire 2 to 3 other variables that we can say, okay. Like for example, we can predict a salary based on your gender, based on your location, based on your pay grade or some other variables. So these are all different kind of variables, okay. You have one variable called y, which is a dependent variable, okay, and then comes the independent variable, and then comes the dependent variables, where all the rest of them, all the other variables are taken into consideration to predict the value of the y label, you can say y prediction values that will be given. So based on all the data points that we have for the x, say your gender, your your age, your salary, and all those parts. So based on that, you can depend, or you can say how many years of experience you have. Based on all that variables, you can define how much salary you should be getting. Okay, so you can see a lot of these these prediction values on Glassdoor is very good example for this part. You can put up all the different labels on it, and that gives you a salary expectation on that, like how much you should be expecting in current location. You can say Mumbai, or say Moscow or New York or anywhere. So that is a very good example of linear regression. Okay, that is a predicting value that you should be expecting. That will give you a range. It will give you a graph of what you should be expecting in this location or in that location, kind of thing. Okay, and for particular data points will be given up, and how they are collecting the data points, that is completely based on your feedback. Okay. Now we'll move on to what exact. Now you could be you can imagine what exactly linear regression is all about. Okay, based on certain values, you are predicting one particular value. Okay, so for this example, I have taken the example of salary. Okay, now we'll move on to the next part. I won't be explaining the entire thing in depth because there are a lot of things that are missing out on the regression part. Okay, and there are chances of error here and there, but that can be solved using parameter tunings and a lot of other models as well. In regression also there are a lot of things. Okay, but for now I'll skip on to the part where I want to show you this model, this this formula, y is equal to mx plus c. Okay, let me just put out a new whiteboard where you can check it out. Sorry, I forgot to keep the Jamboard at myself. Or I can just open a Paint. One second, I'm just sharing it 1 second. Okay, you can see my screen, right? Yeah. So this is a basic formula for y is equal to mx plus c. Okay, as you all know, or you may have learned in your school days, y is the one that we are depending upon, that we are predicting. Okay, this is called the dependent variable. Ignore the handwriting, please. M is the one that is called slope or intercept. Okay, X are the independent variables, where based on these values you will be predicting the value for Y. Okay, please ignore the handwriting again. I am still explaining it. Okay, C is a constant over here. Okay, I'll be displaying to you one of the data set that I have already kept ready for you guys. That is called the salary data set over here. Okay, see, based on the experience that a person has, okay, here are certain data points that we have already taken care of. That's the salary. This is in dollars, definitely. Okay, this is a yearly salary part. Okay, so based on 1 year of experience, you'll be getting $39,000 as a salary, or say something like this. Okay, these are all the data points that we have collected, or I mean, someone may have been connected. So based on this, you can predict what can be the salary for a person who will be having 5 years of experience, or say 6 years of experience. So that can be predicted out of this. Okay. I'll be just showing you the sheet, how this is generated. I'll be showing you right here. Okay, so you have this in Excel, this add-on that is called data analysis. Okay, using this you can predict out of you can get all the regression part, all the ANOVA part, all the variance part, coefficient parts. There are a lot of other things also that you can solve from using this data analysis add-in. Okay, you can just select all these points. Okay, you can just go to data analysis. You have the regression over here. Click on it, and okay, and you will be getting all the options over here. You can just fill out the input Y range. Y range is our B, that is the salary. Input X range, that is our A part, that is the number of years. Okay, and the confidence level. These are certain things that will be getting into in-depth statistics part. Okay, but I won't be explaining to you as of today. Okay, but on the third day you will be getting another information which I'll be sharing with you on the third day. That's on day after tomorrow, you can say. Okay, that will clear out a lot of other doubts as well. So I'll just click on OK, and you can get the complete data sets, and all the predictions and all the things will be given over here. Okay, these are not the final predictions. Okay, you can definitely see these are not the final predictions, but based on this, you can forecast these things. Okay, there is this option called forecast, but that is not utilized over here because the data points are not, these data points are not linear. Okay, because they are non-continuous, you can say. Okay, so that's the reason it's not forecasting as of now. But I'll be showing to you another part, that is using the machine learning model. Okay, so you import the libraries and you have the scikit-learn library that you can predict the linear regression on. Okay, the reason that I'm skipping a bit faster because I want Anu to be explaining the classification part. Okay, so today the linear regression that I am covering is not the data set that Anu will be covering. Anu will be covering an entirely different data set. Okay, and the purpose of that data set is, based on the sensors that we have for, for the food quality. You are measuring the food quality based on the sensors that we have, and based on those sensors, they have given certain values. Okay, in certain units. So based on all those part, we are predicting whether that particular fruit or say that particular food is fresh or spoiled. That data set will be explained to you by Anugna. Okay, but over here, I'm considering only the salary data set as of now. Okay, and I have already put up on run and everything has been printed out. So here I have defined I have called out the libraries that we are utilizing. I have imported the data set on this part. Then you can see salary data. Then I have just run out this entire thing. Okay, I have given the X values. Okay, I have given the Y values. Okay, and I have called out the head part. If you want to also see this data set over here, you can just double click on it and you will be able to see it on the side. Okay, I'm not sure how many people are actually utilizing this function, but I just explored this recently. Even I didn't know this earlier, but yeah, I just explored this on my own. So this is very good, intimation that you can view all the data points and data set over here itself. Okay, so I have called out the head, put out the info as well. So info that we have is 30 data points, and there is no missing values or there is nothing missing out of that. Okay, so we can directly go ahead and pull out the we can split the data set into two, training and the test set. Okay, I have put out the value as 1/3 over here, and the random set is kept as 0 over here. Okay, I have put up only the basic linear regression part over here, and since the data set is pretty small, we don't need to do all the tuning part and all the other things. For now, the data set is pretty small, so similarly, you will be utilizing the same modeling, linear regression part, or say any regression part. Okay, there is logistic regression also. There is all the other the classification models, say KNN or random forest decision trees, neighbors, and anything. All of these can also be used as regressors. Okay, so moving on to the next part, that's the Y-pred. I've just put up this linear regression. I've called out the regression model over here. Okay, I've given it a variable. Okay, I've pulled out the X-train and the Y-train already to train the model. Now I'm predicting it. Okay, based on this prediction, I'm just plotting it out over here. Okay, now you can see this. This is how the linear regression line shows that based on certain experience, how your value is differing, like how your salary is differing. Okay. Yeah, this is the training set. Actually, this is the training set, and based on this training set, how you are expecting the test set. Test set will give you what you are actually predicting out. Okay. This can also be forecasted. This can also be put out into you can say inputs. Input variables can be given so that you can get output variable. Output can be given as what should be the value of the salary based on your years of experience. So it can be 3, 4, 5, anything. And based on that, you'll be giving a certain value. The output value of the salary will be given out to you. Okay. So that's entirely is given through linear regression. Okay. So I've just calculated the performance metrics over here. I'll just close out this salary data set from here. And we have calculated the R2 score, the mean square error, and the square root of RMSE score. So I'll just put out over here. This is called the RMSE score. And this is called out the MSE score. Okay. And this is called the R2 score. R2 as in R square. Okay. Why these values are important and why we are calculating these things specifically is because we are limiting to linear regression as of now. Okay. We are not calculating the accuracy. Okay. Accuracy is majorly focused on, you can say, the classification part. In some sense, you can say that the R2 score, mean square error, or square root of mean square error, all of these are considered as a performance metrics, or you can say a kind of accuracy for the linear regression part. Okay, so this is all about the linear regression that you will have to understand. This is a bivariate. Okay, there are already two variables in this. Okay, that is independent and the dependent variable. So out of this two, you are only getting, one of them is definitely a variable for the prediction part. But out of this, you can also have multiple of them. That's called, multiple linear regression. Okay, if you have, based only here we have calculated based on years of experience. You can also calculate it based on, gender, based on your location, based on your position, based on your qualification. So these are all the other performance metrics that you can, or you can say the performance variables that you can take into consideration to determine the value of salary, or you can say how much your salary should be based on what your other variables are. Okay. And definitely you can also put out the stream rate model. You can build out the model in such a way that you are giving out the predictions on it. You can put out the front end on it. You can build out a good model on it. You can put out on Streamlit and input out this model, and then it can give you the predictions on based on that, and that can give you the scores as well. Okay, so that all can be done once you have a good model and you have big, huge data sets and all. Okay, so that can be taken care of when you have in-depth knowledge about how you are improvising the linear regression part and how good your value is. Okay, these things will be taken into consideration once you are solving the actual data set that now Anu will be taking care of. From now, I'll be handing over the stage to Anu, and she'll be displaying to you how your what model you will be building on. Okay, and tomorrow's session will be taken by Promit. Okay, and he will be showing to you how the model that Anu today will be creating, how that is being taken into a front end, how predicting we are making, how to display those things into a pipeline, or you can say on the front end. And then on the third day, we'll be displaying to you how this particular model is embedded into a tiny ML microchip, a controller that you can say. Okay, so that's all into the rest of the days that will be coming up, and that's all from my end. And right now I'm handing the stage to Anugna. So Anugna, you can take over now, and I hope I have been better as of today, talking a lot after recovering from so many things. Okay, so yeah, go ahead.
Yeah, you were wonderful. You did wonderfully. Hello, everyone. My name is Suram Saraswati Anugna, and I'm a data scientist, and I work at Fascal Engineers, which is my father's company. So yeah, easy jobs. So first of all, before starting my presentation today, I would like to thank Newton for providing me this opportunity to share my knowledge with you guys. Yulia, thank you so much for believing in me. And a special thanks to Soham and Promit for, supporting me and helping me during my learning journey of machine learning. I have been aware of machine learning, say, for 4 years now, and I have been, working with Python language for say 3 years now. So earlier I was using R, but now I'm more of a fan of Python. So for the data scientist or the data analyst, whoever are out there, I say both R and Python are like the go-to languages for us. We don't need to get into Java because I really don't get what Java is. Okay, so that is the other thing. So let me share my screen, and today I'll be explaining you guys the classification model. Can everybody see my screen? Can anyone confirm?
Yes, we can.
Okay. Okay. I don't know why my screen froze. Okay, let's see. My screen froze for some reason. Let me just refresh it. Wow, let me try that. Let's see. Give me a second. Oops. I think my screen froze. I might have to, restart my system. Okay.
That's fine. Take your time.
Yeah, let me just restart my system because I think it froze for some reason. Let me just join again.
Yeah, no worries. Till then, I'll be just explaining to them the data set that we already have.
Okay.
Yeah. All right. So I'll be sharing my screen right now, and I'll be showing to you guys the current data set that we are Anu will be displaying to all of you guys today. Just 1 second, I'll be sharing that right now. I hope you all of you have joined the Slack channel that we have shared with you guys earlier. Just 1 minute, please. Sorry about the delay.
I'm back. I got my system started. It was just because of the Zoom link. It got hanged up. It's working.
Okay, no worries.
Yeah.
Now it's up to you. Carry on.
Okay. So I'm extremely sorry, guys. Sometimes Zoom just hangs up my system. So let's see if it's working now. Yes, it's working. Okay, so let's get started. I believe everyone is aware of the basic machine learning or deep learning libraries that we use. So we'll be starting with NumPy. We'll be calling it as NP, and then we'll be downloading pandas, and then we'll be getting into visualization libraries, which we need for plotting. So we'll be using matplotlib. And then we'll be doing Seaborn, which is called as SNS. And here I have used standard scaler. You guys can use any other scaler that you want to for scaling. And then the simple train test split, which we use for, splitting the data set into training and testing data set. And then we have used machine learning algorithms. So with Tensor Flow, I have taken care of using a few of machine learning algorithms so that we can see how the model is, how the data set is in case of machine learning, and then in case of, TensorFlow. So I have used here logistic regression, which is basically a classification model. So as Soham said, he explained you the regression part, but I'll be explaining you guys the classification part. So I believe you guys can now see clearly. So the basic difference between the classification and regression is, regression is done on continuous output variables, or when you have, float variables in your output, wherein when you have categorical values in your output variable, you prefer to choose, classification models, because the class labels can be easily defined. Say, if you are, trying to say if a customer is going to churn the bank or not. So that's a classic classification problem. Okay. And then say the salary, predicting the salary of an employee. The salary will not ever be, in a class label, or it's not in a categorical form. So salary can be in float numbers or in numerical values. So it's a continuous value. So we use regression there, right? So I'll be taking care of classification. So I have used logistic, decision tree, and random forest classifiers. Decision tree and random forest also have regressor formats of there. So, but here we'll be using classification ones. Then for deep learning or TensorFlow, I'll be using a model called sequential, right? And I'll be using a model of dense, which is basically a number of layers that you want. So there is another type which is called flatten that can also be used, but I have used dense. Then we will be using performance metrics. So no matter how many models you make and how many model fittings, predictions you do, unless you know the accuracy score, or unless you have any performance metrics of it, unless you measure how your model is performing, you don't know. So for that, we need accuracy score. We have classification report, which gives us, the pre-call or the precision, the F1. So these all things come in the classification report. And then we have confusion matrix. And I went a step ahead, and I'm a fan of ROC and ROC curves. So I have plotted the ROC graphs for all the algorithms that I have used on this data set. So I can show you how every algorithm is performing on these data sets. The warnings is something that I use. It's your choice if you guys want to add it or you want to leave it. So it's up to you guys. But this is something that I keep using. So I'm habituated to this. So I keep writing this. So we basically import warnings, and, I just ignore whatever warnings it's giving us. So I'm just going to simply, run this cell and see if there are no errors, and it compiles properly. And it did. So now, before loading the data set, I'll just load the data set. So we'll be using test and train both. So now we have the data sets ready too. So we'll be using the food quality data set here. You can see. So this is basically the label column, which is giving us 1 and 0. So 0 basically means that the food is fresh, and 1 means the food is spoiled, right? So we have multiple sensors reading. So S1, S2, S3, S4, S5, S6, S7. Basically, these are our input variables. So these are basically the sensor readings. So the multiple sensors were used on various food products. And those readings were recorded, and based on that readings, it is decided whether the food is spoiled or whether the food is fresh, right? Wherever you see the number 0, it means the food was fresh. Wherever you see the number is 1, it means the food was spoiled. So this is the basic idea about the data set, right, which we'll be using. So this is the training data set. Let's jump back to our model. So here, basically what we are doing is I have converted into a data frame, and, this is the basic line for reading the data set. So since it is a CSV, so I'm giving it as CSV. If you go here, and type this. So you can have various file formats can be given. So see, you can read a CSV file, Excel, HTML, JSON, pickle, whatever your file type is. You just have to give it in here and it will read that one. So since we are using CSV, so I have given the CSV tag here. So the head, once you have loaded your data set, always make sure to check it's, how, if the data set has been loaded properly or not. So we can see here, you can see clearly rather than the Excel sheet that we have label column, which is our predictor column or the Y column. And the sensor readings from S1 to S7 are our input variables or X columns or X features, whatever you want to call them. Right. So, so this basically printing top 5, head columns of rows of the data set. Then I have used a function called describe. This describe function basically gives you the basic summary statistics of, your data set. So here you can get this mean, standard deviation, the minimum, the maximum, the interquartile ranges, the median. So the summary statistics basically helps you with having an idea about what type of data set it is, and what is the mean, so this basically reduces your workload. Rather than writing mean and median for each and every line, you can just basically have all the things at once with you, right? Then I've used the function called info. So info basically gives you what is the a data type of your data set. So we can see that it is in integer 64, and these all are float values. So you can see all these are float values. And since the label column is like 0 and 1, that's why it is just an integer column, right? And we see there are no null values in it. So all the, all the values are filled. So we don't have any missing values here. So life is easy now because we don't have to do any missing values thing here. So the next thing that we see, we have a dataset length of 980. And here I have printed a correlation matrix. So correlation matrix gives us an idea about what are the variables, what are the features of X column that are influencing our label column or our Y column. So that's why we do this correlation matrix. So if you see like this, you will not understand what is going on. This is basically numbers and all. So what we do is we simply plot a graph like this here. So here, this is PLT. So this is matplotlib PLT, as I have called here. So if you change the values here, you can increase the size of the graph. And I believe you can see it clearly. Right. So this is a heat map. Basically, we use a heat map. So it will show whichever has a higher correlation. It will, just darken that particular column, and the rest of the columns will have a lighter or a darker color based on the relationship with the label column. And then we have a function called annote, which is giving us these values. If I don't put annote here, you'll see the difference. If I take out annote here, what will happen? So this is basically like a plain dumb graph, you can see. So you cannot say anything in it, like what is the correlation number? I mean, like which column is influencing? You can see these two columns are influencing your label, but what is the percentage of it? So that's why we use a function called annote, and we set it to true. Right. So that will give us the percentage values of all the. So this makes more sense. You can see what is influencing your label column. So if you can see that the link, if you see here, I'm sensor 5 reading and sensor 7 readings are highly influencing the label column. Other than that, all are rest in negative. Right. So we have to pay more concentration over sensor readings of 5 and 7 here. Right. So those are the ones that are highly influencing it. Wherein S5 is like, 0.85% influence on it and 72% influence on this. right? So now we come to splitting our data, right? So what I'm doing here is I'm dropping using the drop function, and using the drop function, and I'm taking out label. So we put axis equals to 1 because we are dropping a column. Like axis equals to 1, if we set it, it means the whole column has to be dropped, right? So and then I'm labeling the label column to Y, which is our predictor column. So I have put this double quotes so that it will come into a proper data frame type. Otherwise, the Y will come as just a simple line. So double brackets will give it a proper reading value. So let me just hit run here, and I'll wait for a minute, and let me if anybody has any questions so far on what I have explained, please feel free to ask me, and then we can proceed after splitting the data set. Any questions? And so far, whatever I have explained. Any question, guys? Please excuse my voice, my throat. I have been roaming outside without sweater, so that's why I've got some cold. So my voice is a bit heavy and dusty right now. Any questions? Wow, looks like I'm explaining very well that nobody has no questions at all. Okay. So moving forward, now that we have divided our data set into X and Y variables, so we are basically checking if the label column has been successfully dropped. So we can see that the label column has been dropped from the X. So we have only our input variables in the X column, or in the input features in the X, and the label column in the Y feature, right? So now here we already know the length of DF, but I simply printed it again. It's not necessary. You guys can skip this step. Sorry, excuse me. Okay. So here I have used standard scaler. As I said, you can use any other scaling. So we use scaling so that we can make our data internally consistent and make sure that each data type has same content and format. So it basically formats our data into a proper channel and make sure that we have no discrepancies inside the data. Well, there is a very well-known discussion of scaling the data after splitting or before splitting. So it's a choice, depends on the programmer. If you want to, scale it before, you can scale it, or else you can scale it after, splitting your data into test and train. Depends on you. Here I have scaled it before. So I'll go ahead and, hit run on this scale. And here I'm splitting. So this is basically test and train split. Let me just add that here. So here we are splitting the data. Forgot to comment these. So this is now we are splitting our data into, train and test so that we can, make comparisons and make model fittings and predictions now. So this is to be written as it is. Otherwise, if you make any changes, your test sizes and your train sizes are gonna, vary a lot. So that is X train and X test, and then Y train and Y test. And then we use the test and trains function, and we pass the X and Y variables. Here I have given test size at 0.2. You can write train size. So basically I'm allotting 80% of the data to, training and 20% of the data for the testing. You can write 0.8. It will do the same thing. And then we are using a random state. You can put 42, you can put 100, you can put 200, whatever you want to put a number for random state. So basically, it's going to randomize your data and, okay, what is the error? Okay, so trains, it might be some other function word for training. So I'll just stick to the test for now. Okay, let's stick with test set. Okay. No, it is converted into a. Okay, let me code it here. So I'll write x train, comma x test, comma y train, comma y test equals to train test size. Writing it correct, why it is not taken. Let's see, x comma y equals to okay, comma test. Yeah, test size equals to 0.2 and random state equals to 42. So this should work. Yeah, it's working. So I don't know why it was not working when I tried earlier. So let me just delete this cell. Okay. So we have split the cell into, test and train. So we see the train head now. So if I just type here the shape of X train, we will get to know what is the size that has been split. So let's see that. So we have 784 rows and 7 columns in case of X train. Similarly, for X test, we should check the size. You can use this or you can use the length one also, works fine. So we have 196 rows and 7 columns for this. This is similar for, Y train. I'm just going to print it so that you guys can understand if these things are properly splitted or not. So basically, you can see that only one column, because we have only one column in Y variable. So 784 rows and one column has been assigned to Y train, right? So we can see here, if I simply, run this cell, you can see these have been randomly distributed. It's not like 1, 2, 3, 4 in a sequence order. So we have 481, 974, 667. So these have been randomly assigned because I have allowed a random state. So these have been mixed and, given to the input. So here I also have printed this length, but it's not required, but still. So I'll stop here. And before we start, machine learning algorithms, if anybody has any doubts, feel free to ask.
Yeah, there is a question from Rakwan from over there in the chat. You can take it up.
Shouldn't it be test size? Yeah, it is test size only. I don't know why it didn't, print properly. I think I can try train size now, and it should give me the variable. It should not give me any error. Maybe I spelled it wrong. That's why it gave me an error. Let's see now. Yeah, it's giving me error. I don't know why when I'm trying to do it in this way, it's giving me an error.
You put up the train set instead of size.
Oh, trains. Yeah, size. Okay. Sorry. Yeah, now it should work, right? Yeah,
No,
see, silly mistakes.
there is another T as well.
No, it should work now. I removed it. Yeah, sorry. It's just, like saying set again and again just keeps buzzing into my mind. So please ignore that. So, So works anyway. You can write the train size or you can write the test size. It will take the other part as the test or train, whatever you have given. Right? Any other questions?
Yeah, there is another one.
Does the test dataset contain correct results to benchmark? Daniel, can you just, explain your question, because
Maybe you can elaborate it.
Yeah. Can you just elaborate what benchmark are you
referring to?
Yeah. I mean, X shape has same amount of columns. No, X test does not. Same amount of columns, yes, because the input variables have to be the same, right? The test set and the training set will have same input variables, right? We are talking about X. We are not talking about Y. So Y variable is the predictor. X is the input. So whatever you're giving as a training input variables, you have to give the same for the test also, right? Getting my point? So there will be only one variable, that is the predictor variable. And when you're giving train and test, so basically what you're doing is you're splitting the data set. You already know the results, but just what you're doing is you're hiding some part of the data set from your model so that you just train on this thing and then you make predictions. And we hide this because we already have, this is basically supervised learning, right? We already have the answers for the test data set also. So what happens is we need some kind of, comparison factor. How are you going to compare if the answer is right or not? So basically what you're going to do is you should know the answer beforehand only. Then only you can compare if the predicted answer is right or not. So that's what we are doing. We are just taking some part of the data and hiding it away from the model and giving some to train on it. Right. And then we show the hidden data set to it. And we ask the model to make the predictions on that one. So you'll understand that once I explain you the models. Okay. So that's all questions. No more questions. I'll wait for 1 more minute and then I'll start machine learning.
Yeah, maybe you can get started with the machine learning part.
Okay.
And the detailing.
Okay. So we'll be starting with logistic regression. So if you can see here, so what is logistic regression? I'll explain it to you directly from the links that I refer to. So it's basically a classification algorithm. So unlike a linear regression where you get a straight line between the predictor variables, in linear regression, we get something like an S curve. So zeros are pointed here and ones are pointed here. Right? So this is defined as a sigmoid function, or you can say a logistic function. Right? So this S curve is sigmoid or a logistic function. So basically, we use logistic when we have a classification model. Right? It's very much similar to linear regression, but in linear regression, we use continuous variables. So this is how the graph would look if you, plot a logistic regression. So I haven't plotted the graph, but I'm trying to explain you the most. Since I have already imported the, logistic regression in the beginning itself. So I'm just going to call the function here and not going to, write the import function and all. So I'm just going to call the function. How do you call the function? You just give it a name or a variable name, and you just write logistic regression in a brackets, and it basically calls your function, right? And then what I'm going to do is, then you're going to use a function called fit. So what is fit? Basically, you're training the model. So you're basically fitting the model, we say, right? So we fit the model on X and Y train. So we are training the model. We are giving it the information. We are telling it to analyze this model and find the patterns and form a connection so that you can make predictions when we pass you another data set which is hidden away from you. So once I press hit here, so the model has been fit. So that's why it's showing linear regression as this. Then for predictions, we save it in a variable called YLR. So basically, it is linear regression predictions. So we are saving it as this because we are going to compare it with the Y test then. So we use a function called predict here, and we predict on the basis of X test. So here you can see I'm not giving it the values of Y test, right? So what I'm doing is it has only X test values. Like this is how the X test is going to look like. So let me just print the X test here. X test head. Daniel, if you can see, you'll understand what is happening now. So you see in the X test, there is no variable column called label. So basically what our model now is going to do is it's going to predict the label column for these values, which have been hidden from the model, right? So we use the function predict and it's going to do the predictions. And then we can print the YLR values. If I print YLR dot head, okay, don't need dot head. We can just simply print YLR. So you can see this is how it has predicted for 196 variables, row entries. So these are the values it has predicted for the label column, right? Now we know that it has made the predictions, but how do we know if those predictions are accurate or not? So we use something called accuracy score in case of classification models, right? So what we do is use a function called accuracy score, and we compare the results of Y test, which we already know because we already know we already have divided that data set, and compare it with the LR value. So we see we have an accuracy of 99% here when it comes to logistic regression, right? But this high accuracy score sometimes baffles you, like, okay, am I doing something wrong? Because the moment you see 99% accuracy, you'd be like, okay, something is wrong. If you're not pointing out that such high accuracy, something is wrong, then, you haven't done enough data sets, right? Ideally, anything around 90 to 95 is okay. Accuracy is okay. But as it increases higher than 95%, you should start doubting yourself if you have done any mistakes. So that's why we are printing a thing called confusion matrix. So confusion matrix is basically a matrix value which gives you the true positives, false positives, and true negatives and true false negatives. So as I'm saying this to you guys, you might be scared of what confusion matrix is. It's really confusing, but once you understand what it is, it's really easy, right? So let's see how a confusion matrix looks like. So it's just 2 by 2 matrix, right? So we have true positives, we have false positives, we have false negatives, and true negatives. And based on this, we have all other, recall, precision, specificity, accuracy. These all are calculated based on these specific values. So if you look at this like this, you will not understand what is going on because it's really confusing. So let me show you a picture so that you can understand. So here you can see, I'll just increase the font a bit. So this is, just imagine this is your matrix, okay? So you see here that you have been predicted values and actual values. You can do reverse also. You can put actual values here and predicted values here. Some people do that. You can do that too. But general norm is to put predicted values here and actual values here. So basically it's ones and zeros because we are doing classifications, right? So here it's saying true positives. So you can see the lady is pregnant and the doctor is coming and saying that she is pregnant. Makes sense. Okay, she can see the baby bump and she is a lady. Works. Fine. Okay, so that is true positive. That your actual value is correct and your predicted, like your algorithm also predicted it correct. Okay. Then we have false positives. So this is called a type 1 error, where you can see a man and the doctor says that you are pregnant. How can a man be pregnant? That makes no sense. So what is happening is that actually the value is wrong. Actually, the value is wrong, but whatever the value is, it's 0. But your predicted value is becoming 1 here. Like your model is predicting that it is positive here, which is called as false positive, right? it is negative, but your model is predicting it as positive. Then you have false negative, which is type 2 error, where you can see the lady has a baby bump and doctor is coming and saying that you are not pregnant. Okay, come on, you can see the lady is pregnant. That is right, that actually the result is negative and the doctor is predicting it wrong, right? And then you have true negative. You're saying that a doctor is saying you're not pregnant, which makes sense because he's a man in the first case and he's not pregnant, right? So the model is predicting that it is not true in the correct values, right? So that is true positives and true negatives. I hope you guys understand this. If you don't, please go to this link and read this one article out by Saram. It's very well explained. Everything has been explained, like, recall, precision, how you calculate this. These are some things that you should know as a data scientist. And once you get a hang of it, confusion matrix will not bother you anymore, right? So here we are predicting. So we see that true positives we have that 96, accuracy is 96. So whatever the correct values are, it has predicted correctly. We have one false negative. So here we have see that it was not true, and the model has predicted it to be true. And here we can see true negatives. Wherever they were not true, the model has predicted it to be not true. So that's why we have such high accuracy, right? So this matrix I have shown it here into a heat map, right? So you can see the same matrix in a heat map. So why we print heat maps is we can understand better with heat maps rather than showing a matrix, right? So this is more eye-catching and you can understand what is going on here, right? And then we have a classification report. So here we are getting the values of precision, recall, F1 score, the accuracy is printed here. Sorry. So this is basically the size of the test size that you have passed into the model. Moving forward, we go to decision trees. So decision trees are famous for its issue of overfitting, right? People generally prefer to use random forest over decision trees, but for some data sets, decision trees, tend to perform better. So here I'm calling the decision tree as DT, and then I'm repeating the same, that is basically fitting the model using X train and Y train, right? And then we are going to predict the scores here. And once we do accuracy score, you see it's 100%. So if I do it like, into 100 here, so it's going to show 100% accuracy. So decision tree showing 100% accuracy, clicks an alarm that it might be overfitting the model. So overfitting is basically it has overtrained itself over the, training set and, making the same predictions for the X test also. So similarly, I have done the confusion matrix, plotted the confusion matrix for this. If you guys can see, the 100 is represented as this in a confusion matrix. Right. So I tried a couple of times how to, put 100 here. If anybody knows how to, bring a number 100 here, please do let me know. Because I was trying a couple of times and I couldn't find the code for it. And it was printing it as 1E plus O2. I don't know why. So if anybody knows how to print 100, please do let me know. I'm happy to learn that. And then we have classification report. Right. And now we come to the random forest. So random forest is nothing but an ensemble technique, right? So basically random forest is a number of decision trees forming one algorithm, right? So the word forest means we have multiple decision trees and each decision tree is given a weightage of 1, a voting weight of 1, right? And with the majority wins. If the majority says that the food is spoiled, then the answer of this one would be spoiled, right? So that's how it works. So each tree gets 1 vote and the output is given based on the majority. So in random forest classifier, this is n estimators, which defines how many trees you want to form. So basically you can make 100 trees, 200 trees, 400 trees, whatever you want to make. So since our data set has 980 row values, so I decided to go with 500. You can increase, sometimes you can make 5,000 trees. Number depends on you how many estimators you want, right? So now we are going to fit the model. So you might be well versed with this statement now. Fitting the model, then predicting the model. Here I have printed, for to show you the visually how these estimators are formed. So if you can see here, the random state is such big number. I mean, you don't even imagine such big numbers are given to the random state. So this is basically automatically assigned by the algorithm. So you can see these are 500 decision trees are being made with such random state, and the features are, being distributed automatically. You can define how many max depth you want and all here. But in this case, since we don't have many columns, so I let it be auto. So now I'll show you how to, visualize a random forest tree so that you guys can see how a tree is being formed. So here I'm using a plot here, using tree plot, which basically plots the random forest decision tree and shows you the input variables, how these features are being distributed. Just let's give it a second because it has to, analyze all the features and then make a tree. It's going to take a couple of minutes. Okay, so you can see that it has taken the Gini index. If you want to, use any other one, you can use that. You have to basically mention it, but by default it takes Gini index, right? So that's basically impurity value that we have in the data set. Then it has started with, sensor 4 reading. And based on that, it has started dividing it into different classes. Right here, the class is spoiled. Here, the classes has been divided into, S3 has been divided into fresh and spoiled. Then we have S2 and S5 been divided into fresh and spoiled. So once the Gini impurity is, 0, it means there it ends that tree, like that tree ends there. The more the impurity, it will keep on distributing. So you can see wherever you have Gini impurity as 0, those are the leaf nodes. We call it as a leaf node. So this is the root node, right? So this is root. These are the branches, right? And the end points like this one and this one are the leaf nodes or the end points, right? Leaf nodes do not distribute anymore. The branches do. So you can see here we have impurity as 0 now. So it is not splitting anymore. So we have classes called spoiled, fresh. So it's dividing it based on Gini impurity, right? Now that we have seen how this is just one decision tree that has formed, right? So, but in random forest, we make multiple decision trees. Like I said, we are making 500 decision trees here. So I'll show you how those 500 decision trees look like. So I'll print that here. It should come. Sorry. Meanwhile, this is printing. Any questions? Sorry, my voice has gone down bad. Okay, any questions? Okay. Okay, so we can see, so these are called as estimators 0, 1, 2, 3, 4. So basically it's showing you first 5 estimators. So if you see it in depth, you'll see these are being printed as, the same, this value that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 boxes here. So we see if it's the same here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So yeah, 13 boxes. If you guys want to see, I can increase the size, but it's not going to show anyway. But such trees are going to form, like 500 trees are going to form in such way. Just reduce it back, right? So this is how random forest works. So each tree will have one vote, and based on that, the decision is made whether the food is fresh or not, right? So here we can see the accuracy is one, that is basically 100%. So now we know that there is no overfitting in this case, because we have eliminated that case from decision tree. That overfitting does not happen in this random forest. So we see our accuracy of 100% here. Similarly, confusion matrix. Then you see here true positives and true negatives. So this is all about machine learning algorithms that we have used on this data set. Then we'll be heading forward to Tensor Flow, which is the basic, the main agenda of our event, using Tensor Flow for TinyML. So I'm going to import Tensor Flow as TF here. And then we are printing the version of it. Some people might have the version 1 point something, so you better upgrade your version, because there have been some changes in the TensorFlow, command line and everything. So better switch to the 2 point version. Here I have again printed the length of X test just to check. So as I said, I'll be using the model of sequential here, right? So we'll be using sequential. It's the easiest TensorFlow Keras model that anybody can use, right? So I have called it as a model. And then we have using the units 32 and have activated the ReLU. We are using ReLU, which is basically stand for rectified linear unit. You can use flatten, you can use, other activation codes also. And we are giving it as input dimensions. Whatever we are giving here is X train columns. So we are giving X train as an input here. Right. And then we have same for activation like 64 ReLU using, and then we have a sigmoid activation also, since we have, this is basically predicting zeros and ones. That's why we have used sigmoid activation here. Right. And then we compile our model. So we compile our model and we are using binary cross entropy for loss. So basically we have binary values like zeros and ones. That's why we are using binary cross entropy as a loss function, right? And we are using sigmoid as an optimizer here, right? So that's why I use SGD. And then we have accuracy. So we are predicting the metrics that we'll be using to, predict our performance is accuracy. So we have given that. So let's just run that. And now simply we are going to fit our model. So here I'm using a batch size of 32. You can use a batch size of 64 and see. I have played with a couple of batch sizes and I decided to stick with 32 here. And epochs, I decided to make only 100 neural connections rather than making more than that. So let's see if I can show you the TensorFlow. So why do we use TensorFlow? So basically, TensorFlow has a easy, model building and robust production anywhere, and it's powerful and in experimentation for research. So basically, it's an easier library to access, right, in Python for deep learning deployments and all. So that's why we are using TensorFlow. You guys can go to this website and check out some basic TensorFlow models to work with. This is a neural network model for fashion MNIST. So this is one really great data set to get started on. So this has basically, various types of shirts and dresses in grayscale images. Then you can use a recommender system. So basically it's like Netflix and all. So that's how you can get started with the recommendation system. And then you have this handwriting detection. So these are basic ways to start with TensorFlow. You guys can visit this TensorFlow website and start using these. So it's really helpful for me during my TensorFlow journey. So you guys should definitely check this out. And let's come back to our model predictions. So it's basically the loss here is being, calculated as base binary entropy, and we are getting the accuracy for each and every model. So we'll start this here. So I have tried various epochs like 200, 500, but I finally decided to stick with 100 here. So we see here the model is being built, and let's see what is the accuracy here. Let's go to the top of it. We'll see how the model is being printed. So we see the first epoch had an accuracy of 89%, and it started slowly increasing and then decreasing, and then it's kept on increasing from 89% to, so it kept on increasing. Then I hardly see it going down again. So we come down to 99.36. So the last, from 89% to 99.36%. Okay, so makes sense. Now here we have, fitted our model, and it has so far the accuracy on the training set of 99%. Now let's test it for our, let me just put this on the other line so that you guys can see why I use this code here. So let me just take this off. Okay. And write y hat here. Okay. So now we are predicting our model accuracy here. And you can see our predictions are being made in regression values. You can see here it is like 2 point something, 4 point something. This is basically not a classification data set, right? But we are using classification model on it, right? So how do we do that? So we basically give it a function. So what we are doing is we are saying that in case of y hat, if the value here is less than 0.5, so just point it as 0. And if it's more than 0.5, then, point it as 1. So if we do that and print the y hat here, so it will give us the values properly then. See, it has been printed into zeros and ones. So it has become a classification problem for us now. Right. So our labels have been into zeros and ones now. So this is how you can convert your, regression output into classification in case you're not getting it exactly that one. Moving forward, same accuracy score, as we can see, it is here 99.48. So it has slightly increased, right? And then we are printing the confusion matrix, and you can see here, and then the heat map for it, right? And then the classification report. Now, we know that we have used a model of Tensor Flow, but while we are using Tensor Flow, when it comes to TinyML, when it comes to microprocessors and all, you cannot, fit a huge file or a huge model into it. So you have to basically adhere to some, standards for microprocessors. So we have to convert our TensorFlow model into TensorFlow Lite model. So what TensorFlow Lite is, basically you're compressing your a TensorFlow model into a smaller version of it and feeding it into the microprocessors. Right. So what happens here is, so here I have made a model name and food quality with extension of H5, which is basically a TensorFlow model file extension, right? And then I have printed the file size and, accuracy for it. Let's see what is the accuracy now. So it's 99.49, and you can see it is 28 kilobytes file here. We have that, right? So 28 KB file, right? But once we apply TensorFlow Lite on it, we'll see how the accuracy and how the file size changes. So what we are going to do here is we are going to basically compress the model now, and then again we are going to fit the model and make the predictions. So TensorFlow Lite can be applied in two ways. We can use an API of TensorFlow Lite, or we can use this converter line that I'm using right now. So converter line that we have is TensorFlow converter from Keras model. So this is the command line for, command for converting and compressing the model. Right. So what we are doing is we are creating a TensorFlow Lite model name, and we are writing in that file. So, and then checking the size of that file. Right. So let's just see what happens here. So you see the size of the file has changed. Here it was 28 KB, wherein it is 11 KB now. So the file has been compressed, you can see. Right. So the model has been compressed. When we say the file has compressed, it means it has compressed that, the neural networks that has formed, the connections that has formed it earlier. So those all have been compressed now, right? So now we are going to go into the interpreter, and we are going to check the input shape, input type. So basically we are checking what are the input shape and type here, right? So if you hit go here, you can see it has reduced to 1, 7, 1, 1. This is one row. This is the basically input size of one row and 7 columns, right? And one row and one column for Y. So, but we have the test size of 196, right? So now we have trained the model. The trained model is already there. We are just comparing the accuracy scores here. So what we are going to do is we are going to use a function called resize. And then we are going to, give our test size, whatever the test size is. So you just have to simply print your X test size and pass it here. So you will pass the X test shape, which is 196 and 7. So you have to give your X test shape here. Okay. Similarly for the Y one. And then we are using this, we are printing the input size. So basically whatever we have passed here, what we are doing is we are printing it, whether it has picked up that shape and data type or not, right? So we are printing the data type also, because for microprocessors, we cannot pass input variable of float 64. We need an input type of float 32 only, right? So we have to define the data type also here, right? After that, we are making the predictions here. So here it should be test set. Okay, test images. Okay. So what we are doing is we have created a variable called test set images in NumPy, and then we are passing X test here, right? And we are defining the float type of here. And then the interpreter set TensorFlow input. So this is basically, technical lines that you have to keep in mind once you're running this. So TF Lite model predictions. So basically we are taking the output predictions here, right? And then we are printing the model. So here are the model predictions and axis 1, which is basically we are, checking for the model predictions axis here. So prediction class will be created here. And then we have accuracy scores for prediction class. So we're basically creating a column called prediction class, which will have all the, values that have been predicted by TF Lite model. And we are comparing it to Y test. And then we are basically printing the accuracy score here. So let's just go ahead and print it here. So you see, the shocking thing is that the accuracy has changed to, 50% here, almost like 48.97. So once you compress the model, you have lost all the accuracy that you have here. So that is astonishing, right? Why this happened? Because you have compressed your model, because you have, reduced the size of the model here. It's not able to function at its max. Right, so that's why we have, reduced accuracy here. So this is the accuracy when it comes to TF Lite model, which in case of Newton, you will not face, because even though that you have compressed your model, in the Newton is going to give you the same accuracy as that of, the TensorFlow model that you got here. That is 98. Where is the accuracy? That is 99.48. So that's similar to, nearer to that is going to be given by Newton model, which I'm going to show you after this. So moving forward, then I have printed some ROC curves here. So So ROC curves have printed using the false positive rate and true positive rate. So false positive rate can be calculated using true positives upon the sum of true positives and false negatives. And false positive can be printed using false positive upon false positive and true negatives. So this is a basic formula that you guys have to go through. But once you get a hang of it, you guys will remember it like I do. Right. So basically, I'm printing the true positive rate and false positive rate for logistic regression, for decision trees and random forest and sequential model to show you how these plots are performing. So you can see this is the ROC curve. Let me just reduce the font a bit so you guys can see it clearly. So since the random forest and decision trees have, the same accuracy levels, you can just be seen as a green line. But other than that, you can see for logistic regression, it is somewhere near here. This is not the logistic regression line, so don't confuse it with this. This is a light blue line that is passing behind this red line. And sequential has a 99.5% accuracy here. So that's why the lines have been overshadowed. But otherwise, if they have, a different accuracy scores, so you can clearly visibly see the different model performance here. So this is a way to, show how a model is performing when you have different accuracy scores. So ROC curve is plotted between true positives and false positives, right? So now coming next to the testing data set. So we have been provided with two data sets. As I said, we have a training data set and we have a testing data set, right? So here we are going to run for this. So basically what I'm doing is, so testing data set in this case does not have any y variable. Let me show you that. Yeah, it does not have any y variable here. So you can call it a real-time data set, right? So we are going to make predictions for this real-time data set, right? Generally, if you know Kaggle, the Kaggle will, divide the training and testing data set as training and validation, and then a testing data set. So different words for different data set types, but the thing is the same, right? So we have here we are not going to fit the model because we don't have to train anything. We are just going to simply, predict the model. So here I'm using sequential model predictions. So you can see here, I've called it as a model here. So I'm using the predictions of, just a second, the predictions of model that is sequential. So I'm using that here. So you're directly going to, predict the y variable in case of testing data set, because there is nothing to train in case of testing data set. So here y real, you can see it again has come into, different regular continuous values, regression values. So then we again have to, convert it into our label of zeros and ones. So that's what we have done here. So the simple line that is like 0 if less than 5 and 1 for greater than 5. And that has been done here. Simple as that. Right. And then we go forward. And since we'll be using this for a front end, so I'll be creating a pickle file. So whatever predictions and model fittings that you do, you convert it into a pickle file and you dump it into this. And this has been forwarded to, Promit. And Promit will continue from here tomorrow and show you the, the front end using this model that we have created today. So I'll just hit run and create a pickle file, and you can see I have a pickle file here. The pickle file is represented as PKL, that is the extension for this. So we have other, TF Lite model and TF quality model that we have files that we have created. Those have been also created here, right? And this is the manual way to do it. And then we come to the Newton. So let me show you the predictions. Just wait. I have to sign in again. Meanwhile, I'm signing into this. Please go ahead and ask questions.
Yeah, Anu, can you just show the interpreter once?
Yeah, just a second. I'll show it. So while converting TF Lite, there's a variable called interpreter, but I couldn't catch initial refresh. Okay. So this interpreter is basically, where is it? Yeah. So this is just basically a variable that I created, interpreter, because, I have to give some name to it, and we are using a function called interpreter, right? So basically, it's a conversion file that we use. So that is interpreter, right? So you can see it's an interface for running Tensor Flow Lite models, right? So that is the use of it. I'll keep the screen like this if you guys want to read it out. And so basically, it converts the TF model into TF Lite. Any other doubts?
Yeah, I hope that should answer the question.
Yes, Ellen question has been answered. Then we go to Newton, and here is the food quality results that I have, made the predictions beforehand. So basically, I have trained the model using training here. So we have trained the model, and you can see the accuracy here is 99.999. So it's basically 99%. And this is AUC under the curve. And then we have 99.98 as the accuracy. Sorry. Then we have the precision, the recall, the F1 score, all of the matrix, performance matrix have been printed. This is for the training set, right? And then we go to the predictions, and I have passed the testing data set here. And let's see. That has been done here, and we have an accuracy of 99.98. This is with TF Lite model, right? And I have downloaded the solution here. So since it's a gravity plan, it allows us to, print up to 100 columns, but I think it has printed more than 100 columns in this case for me. Yeah, it has printed more than 100 columns. I think it has printed the whole data set for me. No, not the whole data set. Okay, it has printed up to 421. Okay, still. So you can see here, it has printed, a label column for us, the probability column. So let me just... Okay, so here it is label column, then we have probability columns, and then we have model to this conversion column, and then we have S1, S2, S3, the input variables. So this is how the Newton has, predicted the model predictions for us. So I think, yes, we have used binary classification for that. So this is the Newton's accuracy score with TF Lite model, and you can see that in case of manually, you see that it has been reduced to 48%, wherein with the Newton, it's still the accuracy is being maintained the same as it was before. So that's all from my side, guys. If you guys have any questions, feel free to ask. I'm happy to help, and I'll share my LinkedIn ID with you guys in the chat. So you guys can, connect with me on LinkedIn. If you have any questions, you can ask me there, or on Slack channel. I'm available on Slack too.
Is Newton 3D available? Yes, you can directly go ahead on the Newton platform, and you can just register yourself over there. You can utilize your Google Cloud platform, and that will give you access to the Newton platform as well. Okay, so that should be sufficient for you to get started with the Newton platform. Okay.
Yeah, you have this plan called Gravity, where you can enroll yourself and use Newton. Trust me, guys, it's very fun to use Newton. I really enjoy using it. I do keep checking my accuracies using Newton sometimes. So that's my LinkedIn. Okay, I have just passed it to host and panelist. I'll put it for everyone. So You guys can connect with me on LinkedIn, and any questions, guys, feel free to ask.
Also, another thing I wanted to announce that we have already created a Slack channel called the Tiny ML Competition. So all of you can, be a part of it, and we'll be posting out a PDF file today, and the dataset will be put out today. And what we want you guys to perform is, Anu has already displayed to you the classification part. We want all of you to take care, take your time, explore the data set, and do the regression part using the Tensor Flow. Okay. Or even if you are able to do it, using the basic, the machine learning part, that is also completely okay. And then we can carry forward that particular data set and, the model to the Streamlit file, or you can build up the Streamlit file as tomorrow Promise will be showing to you guys. Okay, so you can build that, and you can then display your you can put out your the Streamlit file on the GitHub, and you can deploy it on Heroku, or you can deploy it on GitHub. You can have it displayed, and you can send out the link to us. Okay, even that should work with us, and we can always evaluate on the basis of all those parameters that we have already set. But yeah, you can definitely be a part of the the Slack channel we have already created for all of you guys. So if you guys have any other questions or any other confusions, doubt, anything, you can feel free to connect with Anu, me, Promit. All of us are already available on Slack, LinkedIn, WhatsApp is also there. So you guys can let us know anywhere. We are happy to connect with you, and we can solve all of your doubts at any point of time.
Sure. And I'll be sharing this Google Colab file with you guys on the Slack channel, if you guys are on Slack channel, or I'll share it here in the chat also in case, if somebody is not on Slack, I'll just share it here. Let me just share the view rights for this.
I hope all of you guys had a wonderful time, going through the entire session as well. And it was informative, definitely, for me as well.
Okay, so I'll just share the link here in the file, in the chat, and I'll share the same link on the Slack channel also. So you guys can, go through how to, split the data set, how to, make, train and test data sets. So these are basic things that you'll be using in regression and classification. So there's not much a difference. The difference comes when you do the machine learning algorithms. So here we have done it with, classification. So you guys will be doing it with regression, what Soham has explained. So I believe you should share your slides also with them so that they can have a basic idea of how to do it.
Yeah, definitely. I'll put it up on LinkedIn, and I'll put up on the Slack channel as well. I'll just put up the slide.
Your collab file also, just share it so that they can have a clear instructions of linear regression, how to use it.
Yeah. That should work. 1 second.
It's really easy, guys. Once you get a hang of it, I mean, like you don't even have to, think twice, and you just start typing and it comes to you.
Even if we share the collab file, there should be the dataset link, right?
Yeah.
We'll be sharing the dataset on the Slack channel as well as on our LinkedIn portfolio as well. Profile as well, sorry. So yeah, you guys can connect over there. And tomorrow, Promise will be taking up the Streamlit part, and where he will be displaying to you how Streamlit is, built up, and we can deploy it on Streamlit, and everything can be displayed in a beautiful way in the front end as well. Like how this model is being working. This is the back end, what you can talk about. This is the basic model that is working in the background, and the front end will be displayed to you tomorrow by Promise. Okay, so do join us at the same time around 8:30 Indian time. Okay, so if there is anything, you can definitely connect with us, and if not, let's catch up tomorrow then.
Yeah, tomorrow's session is going to be even more fun with APIs and seeing what you
A
have
lot of
done
stuff.
in it. So Promit is going to lead that session, and I believe it's going to be really fun. I'm looking forward to it.
Definitely. We all are. So thank you, all of you guys, and have a great day.
Yeah. Have a great day,
ahead.
guys. Thank you so much for connecting with us here today.
Thank you so much, all of you. Have a great day. Bye bye.
Thank you.